All right, hello again, and here we are with section 3.2. This should be pretty quick. It's fairly simple. We're going to be looking at properties of determinants. Now, this is all, of course, for when you're doing a determinant by hand and not on, I know it's on your calculator, so, anyway. All right, so when you have a square matrix, so you can only do the determinant of a square matrix. These are things that could help you make doing the determinant a little bit faster. So remember on the last section, if you had an upper or a lower triangular matrix, it was going to be way easy to do the determinant. All you had to do was multiply the numbers in the diagonal. So if you can get a matrix to be an upper or a lower triangle matrix, then it is way easy to do the determinant. So if we just knew how those changes affected the matrix, then we could just change it to an upper or lower and then do the determinant that way. All right, so that's what we're trying to do here. So we're gonna have to do some row operations to change a matrix to an upper or a lower triangular matrix. So if a multiple of one row, I'm looking right here, if a multiple of one row is added to another row, basically what happens is your determinant doesn't change. So like if we do like 3 times row 1 plus row 2 goes in row 2, it doesn't change the answer. All right. If two rows are interchanged, all that happens is the sign changes. And so that's because of that matrix, that plus minus, that thing, that matrix that was created, that cofactor matrix. All right. So that's why the sign changes. And if one row is multiplied by k to produce the determinant, then basically it's going to be k times that determinant. So that's kind of evident right here. If you notice a row is multiplied by a certain number like k, what you can do is pull that number out front, and it can just be like a multiplier, like multiplying by a scalar. All right. So we're going to try to do these like simple operations to this matrix in example 1. And the first thing we're going to do is my first row looks good, obviously because it has numbers all the way across. My second row looks good, but if I could only just use my second row, if this was a 1, that would be helpful because then I could use it to get rid of some other stuff. So we're going to change that. And the last 2 rows, I think I can get rid of this 2 right here and this 2 right here by doing some row operations with this guy right up there. So I'm going to do -2 row 1 plus row 3, and then -2 row 1 plus row 4. And those simple operations do not change a thing, so I don't have to make any record of that. So when I do that, I have 1, 2, 3, 4, 0, 5, 0, 0. Then when I do those 2 operations, like I said, I end up getting 0, 3, 0, 2, and 0, 5, 1, 3. All right, so now, this 5 right here, this 5 right there, that guy right there, what I'm going to do is I'm going to pull out the 5 to the front and basically like factor it out, kind of like they have right here. And I'm going to rewrite that. So I'm going to pull a 5 out here as a multiplier, and I'm just going to change that 5 to a 1. I don't want to write this all over again. Okay, so now I can use that second row right there to get rid of the 3 and the 5 down below. So I'm going to do -3 row 2 plus row 3 and put that in row 3. Then I'm going to do, let's see what happens with that. So I have 1, 2, 3, 4. That's a little close. Then I got 0, 1, 0, 0. And then I have, let's see, -3 row 2, so it'd be 0, 0. And look at this, let's see, that's still a 0, and this would stay a 2. And then I have 0, 5, 1, 3. All right, so I think I'm going to change these 2 rows. All right, so I'm going to change these 2 right here because that one's looking good for my last row. So what that's going to do is put a -5 in front of my determinant. And so these brackets, darn it, these brackets should be straight. They should not be closed brackets. All right, so now I'm going to go ahead and put a negative outside with my 5, do my determinant, and I have 1, 2, 3, 4. 0, 1, 0, 0. I'm going to switch this to 0, 5, 1, 3, and then 0, 0, 0, 2. All right, so all I have to do is get rid of this 5 right here, and I'm good to go. So I'm going to do, let's see, obviously, negative 5 times row 2, and I'm going to add it to row 3 and stick that right there. All right, so let's see if we can make some space right here. So that would get me to have a negative 5 out front. I still have my 1, 2, 3, 4, and my 0, 1, 0, 0. Down here, 0, 0, 0, 2. So negative 5 times row 2 would get me a 0 there. That means that this would stay a 1, and then that would stay a 3. All right, so here we go. So now I have it. So now all I have to do is multiply negative 5 times these numbers across here, and I'll have my determinant by hand. So negative 5 times 1 times 1 times 1 times 2. So that is negative 10. There we go. All right, so that's it. That's the general gist of what we're doing here. And let's go on to the next example. So we're going to do the same thing here. I see that the top row has a 2 in it, so I'm going to pull out a 2 in my determinant. I have 1, 2, and 3 here, and I have 5, 6, and 7 still, and 7, 6, and 10. All right, so I'm going to do negative 5, row 1 plus row 2 right here, then negative 7, row 1 plus row 2. All right, so that produces for me 2, then 1, 2, 3 stays. If I do those two operations, I get 0, negative 4, negative 8, and 0, negative 8, negative 11. All right, so it looks like I can just do negative 2, row 2, plus row 3 here. Again, that's not changing a thing. So I have 2, 1, 2, 3, 0, negative 4, negative 8. Then if I do that operation, I get 0, 0, 5. So again, I can just use these numbers here and multiply 2 times 1 times negative 4 times 5. And that gets me negative 40 for my determinant. All right, so this next one right here, example 3, we are about halfway through here. So let's see. So using what we were just learning and also cofactor expansion. So look at this nice column right here, right there. It has a bunch of zeros. And so what I'm going to do is I'm going to use that and what we learned last time and this time and do my determinant. So I'm going to have negative 2. I'm going to pull that spot. Now, one thing to remember about that spot right there, that negative spot, remember it goes plus, minus, plus, minus. So going down that column, minus, plus. So I'm going to keep the number that's there. I'm not going to change it. So anyway, if that had been a minus right here, I would have put another minus on that. But I'm not going to do that because it is not a minus. All right, so I take negative 2. Then I multiply, oopsie, no. Then I do times the determinant, and I remember I cross this and this off. So I have 2, 3, 1, 4, 7, 3, and then 1, 2, 4. Okay. All right. So let's do some row operations here. I'm going to do, I guess, negative 2, row 1 plus row 2. Then I'm going to do negative 1/2, row 1 plus row 3 on this guy. All right, so I have negative 2 sitting out here. The 2, 3, 1 stays. And when I do those operations, this is what it produces. 0, 1, 1, 0, and 0.5, and 3.5. All right, sorry, I was just checking something out. Okay, so then I'm going to do, let's see, 1/2, negative 1/2 that is, times row 2 and add it to row 3 to get my last piece right there. So I have negative 2, 2, 3, 1, 0, 1, 1, And when I do that operation there, I get 0, 0, 3. All right, so my determinant is negative 2 times 1 times 3. All right, so negative 4 times 3, that's negative 12. Okay, and so again, obviously, you know, when you have your calculator, you can just go and put this in your calculator and do the determinant, but this is how to do it by hand. It doesn't take that long, and there's your determinant, negative 12. So the next thing is just some rules that you have. All right, so these first two little theorems: a square matrix is invertible if and only if the determinant is not equal to 0. So remember, to be able to do the inverse, the determinant can't be 0, and when the determinant is equal 0, determinant of matrix equals 0, remember that's called a singular matrix. All right, so the determinant of the transpose equals the regular, also the original determinant. So if you switch the rows and the columns, the determinant stays the same. And basically that means that theorem 3 that we had at the beginning, it's going to hold if we replace the word row in that theorem with the word column. Right? So theorem number 6 right here, this is a quick little thing. It says that if you have the determinant of two things multiplied, you can split that up into the determinant of each part separately. So you can multiply first and then do the determinant, or you can do the determinant of each one and then multiply them together, and then you get the same answer. So if I have this, so this is the determinant of a times a times a, right? So a to the third. So what this last rule is saying is that means that is the determinant of a times the determinant of a times the determinant of a. So that, since I was given that was 5, that means I basically have 5 to the third, so 125. Okay. All right, and then this last little piece right here, it says for a and b, show that a is singular, meaning the determinant is equal to 0, if the determinant of b is not 0, and you know that this is true. So, well, if the determinant of ab equals 0, that means that the determinant of a times the determinant of b equals 0 from our rule here, and they just told you that the determinant of b is not 0, so this is not equal to 0 over here. So if something multiplies to 0, one of the things has to be 0, so that must mean that the determinant of a is equal to 0. So you can say, therefore, the determinant of a is equal to 0 to make the statement true and with everything you were told. Okay. All right, so now we just have some little, a few little problems. They look long, but they don't take that long at all. This first one here, I have my my diagonal right there. I have just a upper or lower triangular matrix. Doesn't matter which way you look at it. But if you multiply those four numbers, you get negative 5. Okay, I guess I wrote over them. All right, over here, I can just do a quick switch, a quick swap right there. All right, so when you swap something, remember that it affects your determinant by putting in a negative, because you're swapping those pluses and minuses, plus and minus rows. So you have 1, 0, 0, 0. Then you have 0, 1, 0, 0, 0, 0, 0, 1, and 0. Oh, nope. Oh my goodness. And so those are all ones across, so your answer is negative 1. All right, and this guy right here, very simply, it doesn't matter that negative 9 is there. I still have an upper triangular matrix, so I'm just multiply these ones. My determinant is 1. All right, so in this example down below, you are given that if you have a matrix in this order, A, B, C, D, so this is like a generic problem, you know, all these like 9 letters, that's equal to negative 6. So let's look what happened here. So it looks like right here, let's see, this got swapped there, and then this got swapped there, so there were 2 swaps, 2 row interchanges. So remember that a row interchange means that you are putting a negative sign on your determinant. So I have 2 negative signs because I had 2 switches, and then the original determinant was negative 6. So there's my determinant of this new matrix. So I get negative 6 because 2 negatives make a positive, and then I got my negative 6. All right, this guy right here. This 3 in this row and this 4 in that row can be pulled out. So this is 12. And also, oh look, there's a negative right there. So basically, this is just negative 12 times the original matrix. And so I would get negative 12 times negative 6. So that would be 72. All right, let's see. Letter C. In letter C, it doesn't do anything if you add two rows together or add a multiple of one row to another row. It doesn't do a thing. This determinant is still negative 6. All right, this guy right here. This negative 3, I could pull that negative 3 out. All right, D, E, F stayed in the same place. The G, H, and I basically got added with the multiple of another row, so this didn't do a thing right there. And so basically the answer is negative 3 times the original determinant of negative 6. So my answer here is negative 18. And that is it. No more pages. Yep, that's it. And I'll talk to you next time. Bye-bye.